Hello everyone. Today I'm going to discuss the third problem of Leetcode Biweekly contest 152, which is longest common prefix of key strings after removal. So we are given an array of string words and an integer k. Okay. So for each index I, we have to remove that string from the given array, and after removing, we have to find the length of the longest common prefix among any k strings that are left. Okay. So let's take one example to make you understand better. So let's take this. Let me copy this thing and let me write it here. Let me increase this. So what we have to do, for every string we have to remove that string from the words array. Okay, let's say we have removed the jump string. Now remaining strings are 3 run and 1 jump, and we have to take any case 2. So we have to take any two strings such that the length of the longest common prefix is highest. Okay, so let's say we have taken these two, run and run. Okay, then the longest common prefix here is 3. So answer for the first index is 3. Okay, now let's say we have removed run from here. Okay, we have removed run. Then we have to take the maximum longest common prefix among any two strings in words. Okay, so you can take this jump and this jump. The longest common prefix will be 4, length 4. Okay, so let me write answer will be 4 for this. Similarly for this run also answer will be 4. We can take this jump and this jump, the answer will be 4. Now if we remove jump, then we don't have two jumps, then we can take any two runs, and the answer will be 3 here. So 3 4 4 3 4 is our answer. Okay, I hope you get it. Now answer is 3 4 4 3 4. Now how we are going to solve this problem? So before discussing the solution idea, let's discuss the brute force idea first. How we are going to solve this problem if there are no constants. Okay, now one possibility is that the brute force way is that let's say we have removed one character, one word, okay, from this. Now after that there are 2 to the power n minus 1 number of possibilities of choosing strings. Okay, so let's say we have chosen 2 to the power n minus 1 possible subsets of the strings. Okay, and among them we can find what is the longest possible longest common prefix in the given set. Okay, that could be order of n only. So 2 to the power n minus 1 into n, the problem could be solved in brute force way. Okay, I'm not going deeper in the solution. But the time complexity, if we go brute force way, is 2 to the power n minus 1 into n. But here constants on n is 10 to the power 5 number of words, and the words length also are 10 to the power 5. Okay, sorry, words length are 10 to the power 4. Okay, now how we are going to solve this problem? Now for solving this problem where we have long like common prefix or common suffixes, like only common suffix is the reverse of this problem. So let's only discuss about prefixes. So when a problem comes about prefixes, we have to think about one data structure, which is trie. Okay, so what is a trie? I hope you all know about trie, but if you don't know, trie is a prefix data structure. So this is a trie is a tree, right? Trie is a tree. Initially it will have one root. Okay, now each node in the tree will have 26 children. Okay, 26 children. What are these 26 age determines? The age determines that if there is a string with a here, and the last age will determine if there is a string with z here. Okay, so let's say we want to insert abc in the trie. Okay, let's say we want to insert abc in the trie, so we'll add a node with age of a. Okay, let's call it node 1. Okay, now from node 1 we'll also add one node 2 with the b edge. Okay, now from node 2 we'll add another edge to node 3, which will be will be connected with a c edge. Okay, now let's say we have inserted abc. After that, let's say we want to insert aac. Okay, let's say we want to insert aac. How will we insert? This edge will be common because we are taking a edge from here, so we have inserted abc. Now we try to insert aac. Okay, so this edge will be common, but from n1 we have to take another edge, a edge. Okay, a edge, let's say we have taken a edge, then we come to our node 4. Okay, now from node 4 we can take another edge, c edge, which will be n5. Okay, like that we can create a trie. Okay, now if we want to delete a string from the trie, we can just track the path and remove that node. Okay, So let's say we want to delete ABC. So we'll check that this node 3 contains only one string, so we can remove this. The node 2 contains only one string, so we can remove this. But this node 1 contains two strings, right? It contains also ABC or AAC, so we can't remove this node 1. Okay. So for maintaining that if how many number of strings a node contains, we can also keep a counter at the node. Okay. So let's say there are two nodes at root. Okay, two nodes containing root. Okay, so this will be 2. In1 also responsible for two nodes, two strings, and but in2 and in3 are for only one string ABC. Similarly, in4 and in5 has only one string AAC. So these are the count will be that how many strings are going through this node. Okay, how many strings are going through this node. So there are two operations in this trie we will need. One is insert. I have explained how insert works, and another one is remove. Okay, insert or remove. Okay, erase you can say. So when we are inserting, we'll check if the node exists from the edge. Let's say there is we want to insert BCD from here. So we'll check the B edge does not exist. So we'll create a B edge and we'll create another node N6 from here. This will be inserted, and the count of root will be incremented by 1, and the count of the new node will also be 1. Okay, like that we'll insert, and when we are removing, we'll go to the node and decrease the counter by 1. Like that we'll do. Okay, now this how this trie will help us. Okay, so let's discuss about the insert and erase time complexity. The insert and erase time complexity will be order of n, where n is the length of word. So we can say the insert and erase time complexity is order of word. Okay. So what will you do? I will explain the insert and erase functions later. But what is our approach? At first, we'll insert all insert all the strings in the trie. Okay. At the first step, let me write these steps here. So at the first step, we'll insert all the strings in the trie. Now, at the second step, what we'll do? In the second step, we'll iterate. Sorry, I stopped the recording. So, what are the 5 steps? I am mentioning that the first step will be insert all the strings in the trie. The second step will be iterating over all the words and add the word in the trie. And the third step will be again iterating over all the words, and for a particular word index, remove that word at the particular index from the trie. Now determine the answer for that particular index, and again reinsert the string in the trie. So these are the 5 steps. So insert and remove, I have already explained how insert and remove will work, and only thing important here is that how we are determining the answer for this index. Okay, now for that we'll also maintain one set. Okay, we'll also maintain one set s. Okay, now what this set s will store. Okay, now we have a threshold of k. Okay, so whenever we have one node which has a count greater than equals to the threshold, we'll add the level of that node. We'll add the level of the node in the set. Okay, now what is the level? The level of the root is 0. The level of the next node in1 is 1. Level of the next in4 and in2 is 2, and the level of in5 and in3 is 3. Okay, so whenever the count of that particular node exceeds the threshold, okay, exceeds the threshold of k, we'll add that level of that node in the set, and our answer for after removing a particular word will be the maximum element available in the set. Now I will explain the code. You will understand the solution better. Okay. So what is the solution approach? Okay. Now this is the structure of a node. Node will be like root is a node, and every n1 n2 is a node. So each node will have a count variable which will determine the number of strings going through this particular node, and this there will be 26 edges. The edges will point to the first edge will point to like if there is a edge, and this edge will point to the next node. Okay, like okay, like the children 0 will be pointed to n1. Okay, because there is a age. I hope you get it. Now the trie will contain one root. Root will be initially there will be a root string. Okay, root node, empty root node, and we'll add the strings with this root node. Okay, I hope you get it. Now another multiset ace will be there in the trie class. Okay, this ace I have already explained. This ace will be there in the trie class. Now insert function is that initially we are starting from root, and initially our level is 0. So we are iterating over every character in word, and I is the index of the character. Okay, for A the index I will be 0, for Z the I will be 25. Okay, now we'll check that if the age points to no nodes. Okay, so the ith age points to no node, we'll add a node with that particular age. Okay, now we'll move to that node. Okay, and increment the value of counter of that node. Okay, so let's say we'll check that if there is a age b age here, there is no b age, so we'll add another node, let's say n7, and we'll again move our start pointer to n7, and we'll increment the value of the count for this n7. Okay, that's what we are doing. Now we'll check if the count of that particular node is equals to k, is equals to a threshold. We'll insert the label of that node in our set. Okay, similarly remove is quite similar to the insert, but what is different is that we don't have to check this step. Why? Because we are assuming that if we want to remove a word from the trie, then it should exist in the trie. So that means that the children I will exist, so we'll move to that node, and we'll decrement the value of this counter. Now if the counter value is equals to k minus 1, then if equals to k, then we are adding to the set, and if after decrementing the value decreases beyond the threshold, we'll erase that from the set. Okay, now this is the our main function, you can say. So we are inserting all the words in the trie, and again this is the second step. We are iterating over words and add all the words in the trie. Again we will iterate over the words, we'll remove one specific word. Now if the trie is size, the set size is equals to 0, when will that happen? Let's say the number of words is 1 and we are removing the string, then our set will have no elements. Okay, then if the size is 0, then we are pushing back 0, otherwise we are pushing back the maximum level available in the set. Okay, and after this step is done, we'll do the last step, we'll reinsert the string in the trie. Okay, we are reinserting the word in the trie. Okay, I hope you got the explanation. Now what is the time complexity? Okay, now how many times we are inserting a word in the trie? We are inserting a word twice. And how many times we are removing? We are removing only once. So overall time complexity will be order of 3 into summation of length of words. Okay, words. Now at each insert and remove step, we are doing log n operation. So we can say 3 into length of word into log n will be that overall time complexity. Now another thing to note that is that what is the 3 into length of words? The length of words, sum of length of words is 10 to the power 5. So overall time complexity will be order of 10 to the power 5 into log of 10 to the power 5. So around 10 to the power 6. So this is accepted. Okay. I hope you understood the solution. I will provide the link of the code in the description box. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you for watching.